Very good morning, friends. Today we will see the next topic, that is work energy principle. That is kinetics of a particle using work energy principle. So, what is work energy principle? That you should know first of all. What is work energy principle? Suppose a body, the body it is in dynamics. The body is in a moving condition. So, a body is, you say, see, the first body is moved with a force and it is moving in a right direction, right, right side direction. So here the body is moving and it is from one position to the another position, that is v m, that is this position to the next position. It has traveled a distance of s. So work energy principle, what it says the work done on the on the body or particle is equal to change in its kinetic energy of that body. Right? Change in its kinetic energy in the sense work work done. What is work done? Work done, you know, that is the force into distance. Force into distance. Force, what is the force acting in this body and the distance it is traveled. The force acting in this body, if you see, it is, you have to consider the force acting on the movement direction alone. You should be very careful. You should consider the forces acting along the movement direction. You should not consider the normal forces and all. Okay. The movement direction, what are the forces involved in the body, that into distance will give you the work done. And change in its kinetic energy. Kinetic energy equation, you know, that is half mv square. So change in its kinetic energy in the sense nothing but final kinetic energy minus initial kinetic energy. The body is moved some distance. So that is the final kinetic energy, and you have to find out the initial kinetic energy. Final kinetic energy, you will be using final velocity. Initial kinetic energy, you will be using initial velocity. So you can see this equation, work energy equation, you can see. So what is the horizontal force here? It is asking, yeah, it is acting, that is F cos theta. F cos theta is the horizontal. F sin theta is there. It is normal. You should not consider that. Only force acting there, movement direction. What are all the forces involved? That is F cos theta into distance will give me the work done. Into distance will give me the work done is equal to half mvf square, that is the final kinetic energy, minus half mvi square, it is the initial kinetic energy. This is the equation of the work energy principle. So using this we will try to solve one problem, simple problem. This problem is, I have a block a and B tied with a string through a frictionless pulley. Block A is having a mass of 280 kg, then weight will be 2746.8 newtons. Block B have a mass of 420 kg and its weight will be 4120.2 newton. What is asked in this problem? Velocity. If the block is starts from rest means that initial velocity will be 0, and what is the final velocity after 3.5 seconds? That is what the question asked. The given data is, the coefficient of friction is mu is 0.3. It is given. Now how to find out the work done first of all? So work done is equal to change in its kinetic energy, that you have to use it as an equation. First of all, you have to find out the work done. Work done, it is nothing but what is the force acting in the movement direction. The movement direction is this. It is moving. The body A and B, it is moving like this. So first of all, I have to find out the normal reaction N1 here, N here. So the weight acting downward is 2746, and here B weight is acting as 4120. The points will be there, 0.2n. This is 2746.8n, right? So here this is the normal reaction and this is the weight acting on that body A, this is the weight acting on the body B. Now, what is the force acting on the movement direction? Movement direction, I have a force acting on the movement direction. This is the normal direction to the movement. So, this is the movement direction. I have a force acting at as 4120. 4120 is the force acting in the movement direction. And what about force acting in body A? There will be, it is 4120.2 is in the movement direction, and there will be a frictional force. If the body is moving to the right side, there will be a frictional force on the left side, that is zero point 0.3 into n. 0.3 into n. What is that? That is 0.3 into n. How do you find out n? By solving for vertical equation equal to 0, that is n is equal to 2746.8. N is equal to 2746.8. So, my work done will be the forces acting on the movement direction, that is 4120.2 in the positive direction. In the negative direction minus, I have 0.3 n, that is 0.3 into n. N will be this 2746.8. So, this is my force. This is my force. And what is the distance it has traveled? That is 3.5. So 3.5. So my work done will be this value 11536.56 Newton meter. This work done, I will be using it and I will be equating it to the change in its kinetic energy. So change in its kinetic energy, you have to find out the, first of all you have to find out the initial kinetic energy, then you have to find out the final kinetic energy. The initial kinetic energy we will see, the initial kinetic energy I am notating it as Ti, right? Ti will be half into Ma, mass of first body into Va square plus half into Mb into Vb square, that is velocity of b square, because we have two bodies, that's why I have written two bodies. So here Va and Vb is equal to Vi, V initial, that is the initial velocity of the bodies, right? So I can find out Ti is equal to half into Ma. So the both Va and Vb is equal to Vi, so that I have taken it outside, that is Vi square. I will be having half into Ma plus Mb. So half Vi square, I have taken it outside. So I will get Ma plus Mb. So what is Vi? 0. So the whole term will be 0. So T initial, that is the initial kinetic energy, will be 0. Kinetic energy initial will be 0. Right. So to find out the final kinetic energy, again Va and Vb is equal to Vf. Vf is equal to Vf, that is the final kinetic energy. So final kinetic energy, similarly Tf is equal to half Ma plus Mb into Vf square. So half into Ma is 280 plus Mb is 420, and that is mass of A, mass of B, and Vf is equal square. So half into 700 will be 350 Vf square. So that is my final kinetic energy. So what is work energy principle says? Work energy equation says, that is work done on the body is equal to final kinetic energy minus initial kinetic energy. Work done on the body is 11536.56, already we have got. Then final kinetic energy will be 350 Vf square minus initial kinetic energy, what we have got is 0. Then it is equal to Vf. I can find out Vf square. From Vf square I can find out Vf by taking square root. That will be 5.741 meter per second. That is my final velocity of the body. So that's what after 3.5 seconds. So this is how we have to solve the problems using work energy principle. Work energy principle, what it says? Work energy principle is what it says. Work energy principle is nothing but work done on the body is equal to final change in its kinetic energy. Work done is nothing but force into distance. That force you have to consider acting along the movement direction alone. Into distance is equal to final kinetic energy minus initial kinetic energy. Final kinetic energy will be having some value. You have to find out the final velocity from that. Initial kinetic energy, mostly the bodies will be at rest, so the initial velocity will be zero, so initial kinetic energy will be zero. So I can find out using this work energy equation, I can find out the final velocity. Thank you.